All right, today we're going to trace the incredible story of artificial intelligence. And you might be surprised to find out that its roots don't start with computers or science fiction, but go way, way deeper into the past.
And we're kicking things off with a pretty wild idea, one that connects modern AI to ancient philosophy. This quote really nails it. The core concepts behind how machines learn are much, much older than you probably think.
So let's go way back, over 2 millennia ago. The Greek philosopher Aristotle was trying to figure out a basic question: how do we remember stuff? And he came up with these 4 laws. Think about it for a second. Contiguity: the smell of fresh-cut grass might make you think of summer. Frequency: the more you study a flashcard, the better you remember it. These aren't just abstract ideas. They're basically the first blueprint for how a machine could learn by finding patterns.
Okay, so we've got this philosophical idea. But how in the world does that become a thinking machine? Well, the first giant leap was to stop thinking about the whole mind and instead try to model its tiniest building block, the neuron.
Now, fast forward to 1943. 2 researchers, Warren McCulloch and Walter Pitts, had this incredible aha moment. They realized that a neuron is kind of simple. It has 2 states. It either fires or it doesn't. It's all or none. And because it's so simple, like a switch that's either on or off, you can describe what it's doing with the clean language of logic, a statement that's either true or false.
And from that simple idea, they built this. They translated that concept into the very first mathematical model of a neuron. It's a little device that takes in a bunch of signals, weighs how important each one is, adds them all up, and then makes a simple decision. Do I fire or not? This basic structure? It's the ancestor of every neural network running today.
Look, the big deal with this first model, the MCP neuron, wasn't that it was super powerful. It wasn't. Its real importance was as a proof of concept. It showed, for the very first time, that the act of thinking could, in theory, be boiled down to math.
But there was a huge piece of the puzzle missing: learning. The original model was like a dumb calculator. Its connections, its weights, were fixed. You had to set them by hand. The modern version, the perceptron, is where the magic happens. Its weights are adjustable. It can learn from data and adapt based on its mistakes.
Right. So learning is the key. But how? How does an artificial neuron actually change its connections based on experience? Like our brains do. That was the next critical link in the chain.
So this brings us to a guy named Donald Hebb, a neuropsychologist who, in 1949, came up with a really simple and elegant rule for how this might work in our own brains. The language here is a bit formal, but the core idea is beautiful.
And his idea boiled down to this incredibly catchy phrase that you've probably heard before: cells that fire together, wire together. Simple as that. The more 2 neurons get activated at the same time, the stronger the connection between them becomes.
So what does that mean for AI? Well, it's the secret sauce. It's the basic mechanism for learning from data. Every time a connection leads to the right answer, that connection gets a little bit stronger. It's just like a path in the woods. The more you walk it, the wider and clearer it gets.
Okay, so we've got our building block, a neuron that can learn. But one brick doesn't make a house, right? The next giant question was, how do you put them all together to build something that's actually intelligent? What's the right architecture?
And where did researchers look for inspiration? You guessed it, they went right back to the source, the human brain. Specifically, they studied the visual cortex, the part that lets you see the world around you.
And it turns out, seeing isn't just one thing happening at once. It's like an assembly line. First, your retina just captures light. Then, one layer of neurons picks out simple little lines and edges. The next layer puts those together into basic shapes. The next layer combines those shapes into features, and on it goes, getting more abstract until, boom, you recognize a face.
And this idea of layers, this hierarchy, that turned out to be the absolute game changer for designing artificial intelligence.
Which brings us right here, to the deep neural network. This is a famous one called AlexNet, and you can literally see the layers stacked on top of each other, just like that biological assembly line. The first layers learn to see simple things like edges, and by the end, the final layers can recognize complex concepts like dog or a car.
So, this amazing chain of ideas stretching all the way from Aristotle to AlexNet gets us to where we are today with deep learning. But, and this is a big but, the story isn't over, not by a long shot. Okay, so these systems are incredible, but they're not perfect. And sometimes they make mistakes that are just weird. Take a look at these pictures. What do you see? I'm guessing you see a toy robot on a beach and a wig on a mannequin head, right? Well, a super advanced AI looked at these and, with total confidence, said the first one is a seashore and the second one is a flute. A flute. I mean, seashore, okay, I can kind of see where it's coming from, but it totally missed the main character. But a flute? That just shows you how differently these things see the world compared to us.
And here's the thing. These aren't just funny glitches. They're telling us something really important. These blind spots show that our artificial brains are still just a faint echo of the real thing. Their mistakes often reveal just how much we still don't understand about our own minds.
So when you think about it, this whole journey, from ancient philosophy to simple logic to the wiring of our own brains, it all came together to build modern AI. It really makes you wonder, doesn't it? If today's incredible technology is built on ideas from thousands of years ago, what is the future going to look like built on the ideas we're coming up with right now?